Okay, good morning again. So let's go for some more problem based on angular momentum algebra, whatever we have done in the last two classes. So let's go for, it's a very simple problem. Let's go for this. So we have psi xy as x plus iy. So suppose, and let's say it is -1. So don't worry, it's a -1. So my question is that if LZ will measured on this psi, what will be measurement? If LZ will measured on this psi, what will measurement? So whenever you are approaching this type of problem, you always remember that Cartesian coordinate is a not a good choice to solve the angular momentum algebra. What you will do? You will just convert the thing into a spherical polar coordinate. So in the examination, the examiner will always give you the wave function into Cartesian coordinate. What you have to do? You have to just convert it into a spherical polar coordinate. And once you are going to convert it into a spherical polar coordinate, and for the LZ part, you will just see what is the proportion of e to the power I m phi, and for the L square part, you have to just see what are the theta part. So this is all the story of angular momentum algebra whenever it is given into functional form. So what is my next duty? Straightforward, what you will do, you will just go and convert it into that spherical polar coordinate. So I can put x is equal to r sine theta cos phi, y is equal to r sine theta sine phi. And now, if I will write this all thing at psi r theta phi, you have nothing to do with the r, because angular momentum algebra is all about theta and phi. You remember all this story. So what will happen? This can be written as, I can take r sine theta -1 as common, and what will be there? There will be cos phi plus I sine phi to the power -1. And now I am just only going to taking concern about LZ, and LZ is nothing but minus IH cut del upon del phi. And we know what is the eigenfunction of LZ. The eigenfunction of LZ is 1 upon root 2 pi e to the power im phi. And what is value of m is all, and what is value of eigenvalue? The eigenvalue is all about mh cut. So what we have to do? We have to just recognize what is the value of m for the LZ. So once you will recognize that value of m, then it's a very simple thing. You can just forget this all part. Sine theta -1. This is nothing e to the power minus I phi. So can you tell me what is value of m here? What is value of m here? -1. So your answer will be, if LZ is measured, measurement is -1 h cut, because m is equal to 1. I can recognize here the value of m is equal to, sorry, -1. So this will be the answer. The straightforward, this type of question always come into your examination. Always. So don't worry about this. So it will be -10. Then what will be answer?
minus
This
10.
will be 10.
-10.
-10. M will be -10. So answer will be -10. That's it. So always try to go into a spherical polar coordinate whenever you want to go for it. Okay. And yes, for LZ, this is the prime concern. This is the prime concern for LZ. So let's go for one more problem. Now the psi, let's say psi phi is proportional to sine phi cos phi. This is sine is psi phi is proportional to sine phi cos phi. So what will be measurement if Lz will measured on psi phi? So obviously you can write this thing as 2 times sine phi cos phi by 2. You can write this thing. So this thing is nothing but sine 2 phi. This is just like a fun. And I am just concerned about the measurement. So obviously this number is not so important. So what will happen? Sine 2 phi, how we can write it? Psi phi is proportional to e to the power I2 phi minus e to the power minus I2 phi. So if Lz is measured, what will be measurement? If Lz is measured, what will be measurement?
2h cut minus 2h cut.
Very good. That will be measurement is 2h cut and minus 2h cut. That's it. Okay. Let's go for next one. So what you will do, whenever function is given, you will just write in a basis of YLM. Here we are just talking about Lz. So we are just concerning about e to the power im phi. So whenever you are measuring Lz, you will just write in a basis of e to the power im phi, either in plus and minus. So you will always see that your wave function will be written in form of sine phi, cos phi. This kind of situation will be always there. Okay. Once it will given, just think, okay, I have to break it into term of e to the power im phi and e to the power minus im phi. Okay. So this kind of thing will be always there. Let's go for next one. The state psi is given as root 1 by 6 1 1 plus root 4 by 6 1 0 plus root 1 by 6 1 minus 1. So question number 1, if L square is measured, what will measurement? Second, if Lz is, what is measurement with what probability? If Lz is measured, what will measurement with what probability? Third, find expectation value of L square, Lz, Lz square, Lx. Find the expectation value of all this thing on a state psi, obviously. So we will just calculate each and everything. Okay. So let's go for this. So if L square is measured, what will measurement? If you will measure on this, you will measure 2h cut square. Even for this 2h cut square, even for this 2h cut square. So obviously every time you will measure 2h cut square. So probability of measurement of 2h cut square is equal to 1 by 6, because they are all are degenerate for L square. 1 by 6 plus 4 by 6 plus 1 by 6, that will be 1. So obviously you can see that probability is of getting 2h cut square is 1, because they are degenerate. Because they are degenerate. And you can figure it out. If I will operate L square on psi, you will get exactly 2h cut square psi. So what is this? The problem is very interesting that this psi is eigenstate of L square. This psi is eigenstate of L square. So hence they are eigenstate of L square. You can have probability of measuring that thing is 1. So whenever you measure the eigenstate of any operator, the probability will be always 1. You will be check. You can check anytime. But for the LZ, this is not the state. So why we are not saying that this is the eigenstate for L square and LZ? This is eigenstate of L square, but it is not eigenstate of LZ. Look at here. So if you are measuring for LZ, then probability you will measure for this. The probability of 1 H cut is equal to 1 by 6. Probability of 0 H cut is 4 by 6. And probability of minus 1 H cut is equal to again 1 by 6. And if you will operate on LZ, you can just think, if I am operating on LZ on psi, what you will get? You will get 1 by root 6 H cut 1 1, and this term will 0, and you have minus 1 by 6 H cut 1 minus 1. So this is not a same function. So if it is not a same function, you will have different probability. Don't worry. You will have different probability. So this is a wonderful story. And what will be expectation value of L square? Obviously, expectation value of L square is equal to 2h cut square, because psi will be operated on both sides. And what is expectation value of LZ? The expectation value of LZ is all about 1h cut into 1 by 6 plus 0h cut into 4 by 6 minus 1h cut into 1 by 6. That will be 0. So expectation value of LZ is 0, but expectation value LZ square is not 0, because if you are going to measure LZ square, here you have 1 h cut square, here you have 0 h cut square, but here again you have 1 h cut square. So this is LZ square, and you can easily figure it out what will be expectation value of LZ square. So I am just removing all this part.
सर एक बार ये LZ
So,
साई बता दीजिए।
आप LZ साई पर ऑपरेट करो ना इसके ऊपर। अरे LZ साई को ऑपरेट क्या मिलेगा यहाँ पर 1h कट।
यस सर।
अरे भाई ऑपरेट कर लो ऐसे, LZ यहाँ लिखो, LZ यहाँ लिखो, LZ यहाँ लिखो, LZ यहाँ लिखो, क्या मिलेगा?
ओके सर, हो गया सर।
आइगन वैल्यू तो ऐसे ही चेक करते हैं ना, और कैसे चेक करेंगे? ओके, नाउ so if you are measuring LZ square, then probability of 1h cut square. So if you are measuring it LZ and LZ, so LZ square, that will be 1 by 6. Probability of 0h cut square is 4 by 6. But probability here, if you will measure minus h cut, that will be again 1 h cut square. So this will be 1 by 6. So you can just add it. You have probability of getting 1 h cut square is nothing but 2 by 6. You can easily find. This is the same for LZ square. I am just talking about LZ square. These two are both are same measurement, but for the LZ they are different measurement. And what will be expectation value of LZ square? The expectation value of LZ square is equal to 1 h cut square into 2 by 6 plus 0 h cut square into 4 by 6. So that will be, you can have 1 by 3 h cut square for the LZ square. So please always be very much conscious when operator is, you are measuring the operators. So it's a very important. So let's go for the final one. Let us figure it out. What is the expectation value of LX? Okay. So let's go for expectation value of LX. So what is my Lx operator? You cannot find Lx directly, but you have Lx operator is L plus L
Plus
minus by 2,
by
isn't
2.
it? So what you have to do again, this is, please, you remember the harmonic oscillator problem, how we have done? First, figure it out each and everything, then you can easily couple it. So you can add L plus psi. What will be L plus psi? This number, this will go to where? If I will operate
Into
L
0.
plus
n
what?
plus 1.
0. This is 0 because
Yes.
both are same.
Yes, sir.
So this will be 0. This will be 4 upon
1.
6.
4
This
by
will be go.
6.
So there is coefficient, and that
Yes.
coefficient you can calculate. Please mute yourself. Please, किसी का बहुत आवाज आ रहा है ना? L into L plus 1 minus M into M plus 1 H cut. Remember, this is your C plus, and similarly, you will get the C minus. So you have L is equal to 1, M is equal to 0. So you have root 2 H cut. And this will be 1 and 1. What will happen to this one? Which state it will go? 1 by root 6. Again, you will calculate this thing, that is root 2 H cut. That will be go 1 and 0. So this is your L plus. And let's figure it out. What will happen? L minus sign. So this will be going to lower down, and this will happen 1 upon root 6. Again, you have coefficient root 2 H cut. You know what will be coefficient of C minus? C minus is all about L into L plus 1 minus M into M minus 1. So this is 1 upon root 2 H cut, and which state it will go? 1 and 0. And plus root under 4 upon 6. Which state it will go? 1 and minus, sorry, and root 2 H cut is also there. 1 and minus 1. And this, and what will happen to this state? Please, anybody tell me? 0.
0.
Because you can never write 1 minus 2. This is not possible. So this will be 0. Now I have calculated all my tools. Now I have to put the bra here. So when I will put the bra here, this will couple to whom? So I have to write bra also. So I am just removing this part. So if I will write the bra here, that will be 1 upon root 6, 1, 1, 4 upon root 6, 1, 0, plus 1 upon root 6, 1 minus 1. Isn't it? Now, let's go for find the expectation value of Lx. That will be 1 by 2 expectation. So you have to write psi L plus psi plus psi L minus psi. So this is lengthy problem. So don't get nervous when this type of problem will come into exam. You have to be very patient, and you have to just go for step by step. Now, I have already calculated L plus psi. I will operate bra here. So which term is going to match with? Couple one. All other term will be 0. So this will couple to this one, isn't it? And this will
Yes, sir.
couple to this one. All other term is
Second
0.
one.
Yes. Because if you will write directly, then it is 9 term. You remember 9 term is there, and you have to just operate each and everything, and it will be create a havoc. So best way that just like to just do this problem something like this. First prepare all your tools, then go for this. Okay, so let's go for L plus psi. So this will couple to this one. So what will be here? I have, sorry, this will couple to this one. So I will write the coefficient 1 upon root 6, 4 upon root 6, root 2 H cut. This is going to couple with this one. So this will be 4 upon root 6, 1 upon root 6 root 2 h cut. So this is the story of L plus. Look at how easily we are going to solve. Again, we have already calculated L minus I. L minus I. Again, this is going to there. So this is going to couple with this one. So what will be term? That will be 4 upon root 6, and this will be 1 upon root 6 root 2 h cut. And you have finally, this is going to couple, this is going to couple this one, isn't it? This one is going to couple this one. Both are minus 1. So this is going to couple with this one. So what will happen? Next one is 1 upon root 6, and you have, so this will be 4 upon root 6 and root 2. I think every number is same or different. They are same. 1 upon 2 is there. So I can write it in a very quick manner. You can just check what will be the final answer, but I am just doing this calculation. So 1 upon 2 into 4, and you have, I think, 1 upon root 6, root 4 upon 6, root 2 upon h cut. I think this is the number. And what you have, this will be 2. So you have 4 root 2 upon 6 h cut. And then I think this will be 2 by 3 root 2 h cut. Just check it. Just check it whether it is correct or not.
Yes, sir. Sir.
Yes, sir.
Because I am not able to recheck my calculation because board is very near to me. Okay. Just you can check. The number is not important. The process is important. Okay. Okay. So let's go for next problem. So I am just giving you homework. Just calculate what will be expectation value of Lx square. Can you able to calculate? For expectation value of Lx square, what you need? Should I remove this?
Yes, sir.
Okay. So for the expectation value of Lx square, what you need? This is easier than this one on state psi. I am just giving you homework. For the Lx square, you know this is 1 by 4 L plus square L minus square plus 2 times L square minus Lz square. Remember? So what you have to do? You have to just calculate what will happen to Ls square psi. You have to just calculate what will happen to L minus square psi. You have to calculate L square psi. You have to calculate Lz square psi. And then you can just go for this. So just do it as a homework for the practice. Okay. So it's a very nice practice for this particular thing. Okay. Let's go for next problem. A particle of mass m constrained to and take this mass as mu. Let's say this mass is mu because m will be come into picture. The particle of mass mu constrained to move on circumference of horizontal circle. Circumference of horizontal circle. Circumference of horizontal circle with radius a. Find the energy eigenvalue and eigenfunction. Also calculate the degeneracy. So what will happen? Your particle is moving on a circle, and this is a horizontal circle. This is radius A, the mass is given mu. So first we have to write the Hamiltonian. What will be Hamiltonian for this? So if it is moving in horizontal circle, means it is moving in XY plane. So what will be Hamiltonian? Can anybody tell me?
L square upon 2 m square.
Half m e square theta dot square.
Okay. The Hamiltonian, if I want to write into term of angular momentum, then this will be obviously Lz square upon 2I, because
Yes.
Z is the direction of angular momentum. L square is nothing but Lz square. If you are, we have done into classical mechanics. If you are rotating in a circle, what is the direction of angular momentum? Perpendicular to plane. So if I am rotating the particle in a circle, horizontal circle, the direction is perpendicular to plane. So direction of angular momentum is Lz square. And what is 2I? I is the moment of inertia. And you can find what will be moment of inertia here. You can find Lz square upon 2 mu A square, because this about this axis you are rotating. So this is the direction of Lz, and you are rotating either clockwise or anti-clockwise. This is the thing. So this will be your classical Hamiltonian. So what will be your quantum mechanical answer? So you have to only concerned about Lz square. So what is eigenvalue of Lz square?
M h cut.
Obviously m square h cut square. So E is equal to m square h cut square upon 2 mu A square. And what is value of m? M will be between 0 plus minus 1 plus minus 2 and so on. So this is the eigenvalue, and you can see this is discrete. And this answer is exactly for the particle in box, except m is equal to 0 is also allowed. And why plus and minus? You can rotate particle either clockwise, then angular momentum is upward. And if you are rotating particle in the anti-clockwise, then angular momentum is downward. So this is the answer. And what will be eigenfunction? What will be eigenfunction here? You can have H and Lz is going to commute, because this is same thing. So you have same eigenfunction whatever the Lz. What is eigenfunction? The eigenfunction is phi, and that will be 1 upon root 2 pi e to the power im phi. And what will be degeneracy for the ground state? Ground state means m is equal to 1. So for m is equal to 1, m is equal to 0, phi is equal to only 1 upon root pi. And for m is equal to plus minus 1, phi is equal to 1 upon root 2 pi e to the power plus minus I phi. So what will be degeneracy for this state? How many eigenfunction you are getting here?
2.
2. So every excited state has doubly degenerate, isn't it? What you have this value of energy, Em is equal to m square h cut square upon 2 mu A square, and you have two eigenfunction e to the power, and you can write 1 upon root 2 pi e to the power im phi, and you have for 1 upon root 2 pi e to the power minus im phi. For all higher state, you have doubly degenerate, but for the ground state, you have non-degenerate. So for this type of function or this type of problem, you have for ground state, degeneracy, ऐसे लिखते हैं, for ground state degeneracy is 1, all other excited state degeneracy is 2, G is equal to 2. And you can see, if we know the LZ, we can find each and everything. Okay. If you have any doubt, you can just ask me. This is a very simple question. Just think, this is very simple. And if you are not try to convince with this logic, we can go for another logic also. And we will get the same answer. What will be next logic? Next logic you can think. So is that clear? Okay, up to this point?
Yes.
Okay. So what you can do, you can write Hamiltonian is nothing but L square upon 2I. And what is your L square? Your L square is minus h cut square upon 2I. And this will be del upon del theta sin theta del upon del theta plus 1 upon sin square theta del square del phi square. Isn't it? You can just take L square. L square यही होता है ना? So I have written some wrong thing. I think this, okay, sorry. So this will be 1 upon sine theta is also there. 1 upon sine theta, sorry. So this is the thing, L square. Now, if it is rotating into horizontal circle, then theta is equal to what? Pi by 2. Theta is fixed. So if theta is fixed, then this part is going to 0. This part is 1. What you will have? You will have minus h cut square del phi square upon 2I. And what is this thing? What is this thing? Please
LZ.
tell me. LZ
LZ.
is square. LZ is square, not LZ. This is LZ square. LZ square upon 2I. So I am getting the same answer from mathematics also. LZ is what? Because LZ is minus IH cut del upon del phi. That's it. Let's go for next problem. If rigid rotor of moment of inertia I rotate in a space and this is about center of mass. Moment of inertia about rotate in a space about center of mass. Find the energy of rotor. There is not any potential energy, nothing else, only some rotor, and they have moment of inertia about center of mass. About center of mass. One liner. What will be answer? And they are rotating in a space. Suppose this is your rigid rotor and this is rotating in a space. That's it. About center of mass. One liner. What will be Hamiltonian? Simply L square by 2I. And this is moment of inertia about center of mass. What is eigenvalue of L square? You get L into L plus 1 h cut square 2I. So this is your energy of rigid rotor. You will learn this thing into atomic physics also. But I am just doing the just exactly using the quantum mechanics knowledge, and we are doing all this stuff. And what is value of L? Obviously 0, 1, 2, 3, and so on. And what will be degeneracy of each state? 2L plus 1. Simple, because I am only concerned about L square. You know, if there is any rigid rotor, it is rotated about this thing, about some axis. You have to just figure it out what is your L square. In last problem, L square is equivalent to LZ square because it is constrained to move in in XY plane. So here you have take the whole L square, that because it is rotating in whole space about the axis. Okay. Are you getting it?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Okay. So let's go for, so this is the all problems. So let's go for one more thing. How we will write the matrix form of Lx, Lz, Ly, and L plus L minus kind of thing. So obviously, let's try to write matrix representation of L square, Lz, L plus L minus for L is equal to 1. So we have to just write the matrix representation, and we know how you can write the matrix. So for L is equal to 1, we have following kit 1 1, 1 0, and 1 minus 1. So this will be 3 cross 3 matrix. So you have to just write, this is your L square 1 1, 1 0, 1 minus 1, and you can write 1 1, 1 0, 1 minus 1. L square will go to this 2h cut square, and this will couple. All other term will be 0, 0. This will be 2h cut square 0, 0, 0, 2h cut square. So this is all about your L square. What will be Lz? Again, you will write the same thing 1 1, 1 0, 1 minus 1. You can just figure it out 1 1, 1 0, 1 minus 1. So the first term will be 1h cut. All other term will be 0 because they are orthogonal. This is 0, this is 0h cut, and this is also 0, and this will be minus 1h cut. So this is all about Lz. And let's figure it out. What will be L plus and L minus? This is very trivial, very simple. Are you going to understand this thing?
Yes, sir.
Okay. So let's go for L plus and L minus. So again, we will just get, this is L plus 1 1, 1 0, and 1 minus 1. And you have 1 1, 1 0, 1 minus 1. L plus will go to this. This is 0. This will be 0. This will be again 0, because not any other term is going to sorry, this have some number. Sorry, this will have some number. So L plus will operate on this. This is root 2 h cut 1 1 and 1 1 will be there. So this will be root 2 h cut. Other term is 0. This term is again 0. And again, this term is 0 because it is 1 1. And this term will be 1 0. So this will be root 2 h cut. And all other term will be 0. So this is upper triangular matrix. Isn't it? This is your diagonal. The upper part you have some number. Similarly, you can get L minus. And once you will get to L minus, that will be 1 1, 1 0, 1 minus 1. You have 1 1, 1 0, 1 minus 1. L minus will go to this. This will be 0. Obviously, this term is 0. L minus will go to this. This is root 2 h cut. So this term will be there. This will be 0. And here you have root 2 h cut 0. So you have L minus also. But why we have finding L plus and L minus? Because we can figure it out what is my Lx. And please look at L plus and L minus is not a Hermitian matrix. They are not Hermitian matrix. But if you are going to calculate Lx, and this will be L plus L minus upon 2, then you can find that matrix is actually Hermitian in nature. And what will be this matrix? This matrix is 0, h cut upon root 2, 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 0. This is your Lx operator because 2 is there. So 1 by root 2 will be always there and you can find. And this matrix is Hermitian. And without calculating, can you give me what will be the eigenvalue of this one? Without calculating.
0, 0.
I have given you clue. What will be the eigenvalue? What is eigenvalue of Lz? 1 h cut, 0 h cut, minus 1 h cut. So here you will find the eigenvalue 1 h cut, 0 h cut, minus 1 h cut. So because I have told you that Lx, Ly, Lz you can take anything. But best thing is that why we are not taking Lx? Because Lx and L square is not simultaneously diagonalized. Even they are commuting. We cannot find some function on which basis both are simultaneously diagonalized. Look at this thing is very basic. Obviously, this will not ask into your exam this deep-rooted thing, but somebody can ask this thing into your interview. Why didn't you take Lx? What is L square? Look at L square. This L square is 2h cut square 0 0 0 2h cut square 0 0 0 2h cut square. This is your L square. And what is your Lz? And Lz is equal to 1h cut 0 0 0 0 0 0 0 minus 1h cut. Look at in the basis of 1 1 1 0 1 minus 1. Fortunately, these two things are diagonalized. But in a same basis, this is diagonalized, but Lx is not diagonalized. So we always try to figure it out that our operator, we will figure it out the basis in which our operator must be diagonalized. This is one of the very important thing. So why we discarded Lx? In spite of after getting that Lx, you can figure it out that eigenvalue is this one. I am just giving you homework. Just figure it out what will be your eigenvector. And this is all about part of matrix, eigenvector. Here what is your eigenvector? Eigenvector is 1 0 0 0 1 0 0 0 1. And 1 0 0 is actually I am writing 1 ket. 1010 is I am writing 10 ket, and here I am writing 1 and -1 ket. So this is the wonderful story. You can just understand and you can just figure it out about the matrix. We will again go into next level of the spin. Then this matrix form is going to more clear into a spin part of this, because their calculation is very easy. So we will figure it out, that calculation. But I am giving you homework. Just please figure it out. What is the eigenvector of corresponds to 1 h cut, 0 h cut, and minus. First, you have to figure it out what is eigenvalue. Then you have to figure it out what is eigenvectors. Okay. So this is from my side of understanding the basic nature of angular momentum in a quantum mechanics. So this is all about end of your lecture. So if you want, you can raise any doubt. So tomorrow we will just go for a spin, and that is same thing we are again repeating. So not any problem. Same thing, same concept, same thing. Everything is same, but yes, spin has different symmetry. They have also rotational symmetry, but they have same algebra, same rotational symmetry, but purpose of a spin is different. So if you are not concerned about any question, should I leave?
Yeah, sure, sir.
Okay,
Yes,
thank
sir.
you.
Thank you,
Yes,
sir.
Thank you, sir.
Thank you.